Hi and welcome everyone. In this video, I want to go over finding the eigenvalues of a 3x3 matrix. Now, before I go over this example, please watch the video on eigenvalues and eigenvectors. I made one on that. And there is one on diagonalization. So that's why you use eigenvalues and eigenvectors. And I just, for that example, I used the same matrix. Now, in that example, I gave you the eigenvalues, but I want to go over the details of finding them in this video. So let's go ahead and start. So now to find the eigenvalues, what we need to do is to find the characteristic equation. Again, watch the video on eigenvalues and eigenvectors, and you're going to see how do you make the characteristic equation is the determinant of lambda I minus a, that matrix, or the determinant of a minus lambda I. They are going to give you the same answer, whichever one you're more comfortable you can use. Now that matrix lambda I minus a, again, this matrix is lambda I is that matrix, minus a is our matrix that we want to find the eigenvalues. So if we subtract these two matrices, then again, we subtract the corresponding entries. So the first one is lambda minus 1. The second entry here is 0 minus -1, which is 1. 0 minus -1 is 1 here. And I think it's pretty straightforward. So you just subtract and you get that equation. And I usually use this one because I want to get positive values in front of my lambdas, but it doesn't make any difference. So now once you find this matrix, you have to find the determinant of this matrix. So what I did is, so you can write the determinant, and then I expanded this along the first row. So it's going to be lambda minus 1 times the determinant of that matrix, which is right here. Then it's -1 times the determinant of that matrix, which is right here. So, and finally 1 times the determinant of that matrix, which I wrote it here. So now if you simplify this, again, it's lambda minus 1, the determinant of that matrix is lambda minus 3, is that times that. Lambda minus 3 is lambda minus 1 minus that times that, or that times that. It doesn't make any difference. So it's right here, same as this one. So it's -1 times lambda plus 1 minus -1 times 3. So it's right here, and we have the determinant of this matrix. So the one just goes away, -1 times -1 minus 3 times lambda minus 3. And you can just simplify those. Again, it's simple algebra. And if you simplify, I just went step by step, then that expression, you can just expand it, you get that, and then you can expand this one. So if you expand everything, that's what you get. And if you simplify or combine all the like terms, you get a polynomial. So this is the characteristic polynomial, and you have to put that equal to 0. So this is our characteristic equation. Now, how do you solve this? This is a good one because you can solve this by factoring, and I factor that by grouping. So it's pretty straightforward. The greatest common factor is lambda squared times lambda minus 3 minus, then you take the 4 out, times lambda minus 3 again, and you know this is a common factor. So you get lambda squared minus 4 times lambda minus 3, and you can factor lambda squared minus 4, and finally you set every single factor equal to 0, and you get those values. Now the video I made on the diagonalization, I show how to find the eigenvectors on that one, so please watch that one. Also, now solving the characteristic equation, sometimes you have to use synthetic division. So if it's third or fourth degree, to review synthetic division if you get a question like that, so you know how to deal with that. So usually they're not going to be very difficult. So they're going to be solvable, but make sure you know synthetic division also and how to solve polynomials or the zeros of the polynomials. I think that's it for this video. Thank you for watching, and I'll see you on my next one. Have a great one, everyone.